All right, we want to talk about thinking about large numbers and infinity. And we're using the lazy 8 symbol for infinity. We need a language to talk about large numbers. And in the 1980 series Cosmos, Carl Sagan used exponents on 10 to write large numbers. For example, 10 to the 3 is equal to 1 followed by 3 zeros. 10 to the 5 is equal to 1 followed by 5 zeros. There was a mathematician by the name of Edward Kasner who was interested in a large number, 10 to the 100th. And that would be 1 followed by 100 zeros, and I don't have enough room here to write that out. That mathematician Kasner asked his 9-year-old nephew to come up for a name for this large number. And that nephew came up with the name Googol. And you notice it's not spelled like the web search engine Google. Now 10 to the 100th is an extremely large number. And if you counted up all of the particles in the universe, all of the protons, neutrons, and electrons, the whole total in the universe would be about 10 to the 80th. So 10 to the 100th is a very large number. And then there is even a larger number that has a name, and that is 10 to the 10 to the 100th, and that is called a Googol plex. But how do these numbers compare to the number infinity? Well, if you ask yourself, how far away is the number 1 from infinity? And how far away is a Googol plex away from the number infinity? They're both the same. They're an infinite distance away from infinity. Now we want to think about infinity. We've talked about it already, but now I want to try to give you an interesting example of how to think about the number infinity. So let's suppose we wrote down 0.3333. And we multiplied that number by 10. We would get 3.333. And you can see if we subtracted these numbers, we're going to get something from this side because there's not a 3 here to cancel it. But watch this. Let's look at the number 0.3333. And now we're going to say it's a repeating decimal, so it means the 3 goes all the way out to infinity. So 3333 all the way out to infinity. Now let's multiply that number by 10. So if we do that, we would get 3.3333, again repeating all the way out to infinity. So there's an infinite number of 3's on this side of the decimal point. There's exactly the same number on this side of the decimal point, even though we have shifted over 1 3. It looks like we took 1 3 away, but there's still an infinite number here and an infinite number here. So if we call this number x, and we call this number 10x, and we subtract them, we'll get 9x here, and that is equal to all of the infinite number of 3's here, cancel all the infinite number of 3's here. That's what's given us an idea of infinity now. So we're left with exactly 3. So if we solve for x, we get x equals 3 over 9, which is 1 over 3. And everybody knows that's the repeating decimal. And now if those 3's didn't cancel out, we would have never found that x equals 1 over 3. But they all cancel out. The infinite number of 3's cancel out. So I hope that gives you an idea of infinity in terms of repeating decimals all the way out to infinity. Now, people don't generally use the number Googol and Googolplex, but there is a large number that most of us have heard about, and that's Avogadro's number, and that's 6.02 times 10 to the 23rd. And that's the number of, say if you have a mole of helium, that would be the number of helium atoms in 1 mole of helium. So we can have a little fun with that number. And Carl Sagan used to talk about the number of stars in a galaxy. And the number of stars in a galaxy is 100 billion. So that's 100 times 10 to the 9th, which is 10 to the 11th. So we could say there are 10 to the 11th stars in the galaxy. How many galaxies are there in the universe? Well, it turns out that there are also approximately 10 to the 11th galaxies. In the universe. We almost have Avogadro's number. Now, if we ask how many planets there are per star, and we'll just say based on our solar system, we got roughly 10 if you count Ceres and Pluto. So let's say we have 10 planets per star. So if you work this out, you wind up with 10 to the 23. Add up all the exponents, 11 plus 11 plus a 1 here. 10 to the 23 planets per universe, in our universe. So I always thought it was interesting that, roughly speaking, very roughly speaking, the number of planets in the universe may be very close to Avogadro's number. And my name is Ochadlick.